Okay, so here's an example that I was referring to earlier, in which now we're going to have to use some of the counting principles I mentioned earlier to compute a probability. So it's kind of like we're combining the two ideas of the two previous videos into one here. And so, here the scenario is we have 8 streets and we're going to name them after 8 tree types. And so here are the 8 trees, and we're going to name each one of these streets. All right. And this city planner is now randomly selecting these. It's just again, that's just what they're doing here. And we want to find the probability of each of these two events. And so we look at each of these two events as separate events. And we're just interested in the outcome of the first one occurring. And so here you could see that the first street is cedar, followed by oak, then spruce, then fir. So even though it doesn't say order is important here, it's implying that order is necessary to determine this event. Okay. And so what we want to do is we are going to count up here first, just to see what the solution to these are here. This order here is unique. So there's only one way that that can happen, where cedar is the first and then oak. We're not going to double name a street, right? That doesn't make sense. So we basically have to come up with this number out of all the possibilities, which are 1,680. Okay. Well, that can be determined here by using our calculator here. So I'm going to have to kind of bounce back and forth here. So, so we have 8 tree types, right? Okay. So where does the 1680 come from? Well, again, we were picking all 8 of them. So one of the things that I could do is, first of all, I'm going to show you the easy way to do it in terms of typing it. And that is, I'll just kind of clear all this stuff out here, just so we're not overwhelmed by it. But we have 8 things, right? And order is important. So we're going to go and again, just select the permutation here for the probability, and we'll select that first one. And so therefore we have 40,000 and 200 and what is it? 40,320. So that's how many possible things we have here in terms of these streets, if that would be all 8. But here we're actually only going with first, second, third, and fourth. And so what that tells me now is that I need to go ahead back here. And this is just kind of setting the ground here. If we would label all streets, that's how many different ways we can put them in where order counts. Okay. And I'm going to clear that out. And I'm going to go to my math menu and back to the probability. If I could do that correctly, select that. Let me try that one more time. I'll do 2 more here. And I'm going to choose the permutations again. So I have 8, but I'm only selecting 4 out of the 8 here, because it was just labeling the first 4 that one unique way. And there's your 1,680. Okay, so that's where that denominator. So there's only one way that that can happen out of the 1,680. Now, where does the 70 come from? Well, now the first 4 streets, again, it doesn't matter which order. It could go cedar, birch, spruce, oak, or oak, spruce, cedar, or whatever. They're all considered to be the same. And so I'm just going to go ahead and use my combinations formula here. And when I do that, let me go back to the math menu here. I'm not going to edit that command. I'll choose number 7 here. So one by it. So here again, I will type in my 8,4, and there again is the 70, which is again what we have over here for the denominator. So all we're doing here is counting up the number of possibilities, right? By using, the permutations and the combinatorics or combinations formula. And pretty straightforward. Okay. The other video, again, we were looking at a bag of marbles. It was really easy to count up the number of possibilities. okay, just by looking at a picture, or maybe, with just a simple scenario where we're multiplying numbers that are given in the beginning using multiplication, or just adding up the total number of outcomes, just again, based on some sort of diagram. Here, got a little bit, if I would, do a tree diagram here, it would just get overwhelming. Okay, so that's why those formulas are very useful for, doing probability problems like this. Again, I know this doesn't sound like a very applicable problem, like, someone would just say it doesn't really matter, who cares what the probability is if you randomly select them or whatever. There's not much meaning, in terms of a meaningful application here, I guess I should say. But nonetheless, again, like I said, we're going to build on these ideas, and later on they are going to make sense, and they are going to be important to us. So, all right, so we'll see you again next video. And sorry for my dog barking there in the background. Try to keep him quiet while I'm making these.